Assalamualaikum warahmatullahi wabarakatuh and hello everyone. In this video, we're going to discuss the third hour tutorial for benzene and its derivatives. So for question 1a, non-face-to-face, what is the product formed when benzene react with 2-chloro-3-methyl-pentane? So you're given the name of the compound, then you need to illustrate it in terms of the structural formula. So now we're going to first react the benzene. So first we have the benzene like this, and then we're going to react with 2-chloro-3-methyl-pentane. We're going to start from the carbon chain. The longest carbon chain going to be pent 5 carbons. So we have 1, 2, 3, 4, and 5. And at carbon number 2, let's say we'll start the numbering from the left. We're going to have chloro attached to the carbon number 2. And at carbon number 3, we have methyl group. So our product gonna be alkyl benzene, but what kind of alkyl benzene will be formed throughout these reactions? So please be remembered that we're gonna have major product as the most number of molecules being formed. So we need to first look at the classes of carbon present in this structure. So we have primary carbon, secondary carbon, and tertiary carbons. The reason why we need to look at this because we're going to form carboxyl ion in the middle. So we need to look at what kind of carboxyl ion can be formed. We initially are going to form secondary carboxyl ion, but if we have the possibility to get a more stable carboxyl ion, then we need to do something called rearrangement during the first steps. So we're going to take this tertiary carboxyl ion to form the major product, means the alkyl benzene gonna be inserted at the carbon number 3, giving us the product of benzene. And then we have this bond attached to third carbon. If you look at the third carbon here, we have the environment of 1, 2, 1, 2, means we have 1, 2, 1, 2, like this. And don't forget, the methyl group attached to the carbon number 3 means we got another alkyl group here. So we're going to get this kind of product together with the side product of HCl. Don't forget to write the conditions required for these reactions where we need AlCl3 or FeCl3 to help with the formations of electrophile. Now let's proceed to question 1b, where you need to outline the mechanism for these reactions. Since this is an electrophilic aromatic substitution, means we're going to have all 3 steps. So we have step 1 of the formations of electrophile. So we need to rewrite our haloalkane. So we have 2-chloro-3-methyl-benzene, show all the lone pair on this chlorine, and then we're going to react them with AlCl3. So from these reactions, we're going to form a complex ion of 1, 2, 3, 4, 5. Don't forget the methyl. And at this chlorine, we have already donated one of the lone pair to form bond with the AlCl3. And if we check the formal charge, this Cl will have a positive charge while this Al gonna have negative charge. You need to choose whether you want to break this bond already or not. Since we already have 2 alkyl group attached to the carbon that bearing the Cl, then we can simply break the bond because they are already stable. So we are going to get 1, 2, 3, 4, 5. So we're going to have our carboxyl ion in here together with the AlCl4 minus. Alright, so at the moment we have secondary carboxyl ion, but the neighboring carbon suggests you to get primary and tertiary. If you have the possibility to form a more stable carboxyl ion, then you need to do the rearrangement. So what kind of rearrangement that can we do for this compound? So look at your neighboring carbon that we are interested in. We are interested in the carbon number 3. So initially we only have 3 bonding. Since this is a skeletal structure, means we have another hydrogen attached to this carbon. If our neighboring carbon got hydrogen present, then always go for hydride shift. So we're going to swap place of this hydrogen with the carboxyl ion. Since we are involving hydrogen, so means we are going to do 1, 2, hydride, shift. We'll have a new carbocation at carbon number 3 like this. So we are going to bring these carbocation to the second steps. As for the second steps, we are going to form the uranium ion, where we are going to involve the reactions between the benzene and also our carbocation. So first, draw the benzene. Okay, so the benzene gonna react with our carbocation. 1, 2, 3, 4, 5. Our carbocation is in here. So this double bond will attack the carbon in the middle at carbon number 3. So then we're gonna form the resonance structure of this uranium ion. 1, 2, 3, 6. So we're gonna have carbocation in here. H, 1, 2, 3, 4, 5, 6, like this. And then we have a resonance structure. Once we have changes place of this double bond, so we're gonna have another uranium ion with carbocation in here. H, 3, 1, 2, and 1. So swap of these double bond to here, and lastly our uranium structure, uranium ion gonna be H. Here and here, don't forget the positive charge. So these are our resonance structure. So now we'll proceed to the step number 3, where we are going to lose the hydrogen from the carbon. So step 3, we'll take one of the resonance. So we have H positive. To react with the AlCl3. So we have AlCl3 negative with the Cl. So first, the bond between this Al and Cl will break, forming negative charge. This negative charge of Cl will attack the hydrogen and retain the double bond inside the benzene. And lastly, our product gonna be benzene together with the alkyl group of together with the HCl. Let's proceed with face-to-face questions for this hour. So we are given these reactions, which starts with benzene and then react with reagent X. Then we're gonna get this kind of product with acyl group on it together with the HCl as a side product. So we need to determine what kind of reagents X will be used to get this kind of product. You initially have benzene, means this is gonna be your reagents. But then if we break the bond between this benzene and also this carbonyl group, means we are going to have an electron division species. In order for you to know whether this compound can come on its own or with the help of the other atoms, look at the side product. So we could see that we're going to have a carbocation as the intermediate, and then they're going to combine with the negative charge. So H is a positive charge while Cl is a negative charge. It means that our C double bond O gonna bonded to this Cl. So we could say that our reagent X will be 1, 2, 3, 4 with methyl group in here. Don't forget the double bond O. And then we have chlorine attached to it. So this is what we call the acid chloride. And then with the presence of AlCl3, or maybe you can also use FeCl3 as the catalyst to increase the polarity for the reactions to occur. Now we'll do the mechanism for these reactions. Again, since these involve the reactions on the benzenes, means we're gonna have the 3 essential steps. So step 1 will involve the reactions between this acyl chloride. So we have 1, 2, 3, and 4. So 5, we have O. Cl in here. Don't forget the methyl here. React with the AlCl3. Now the lone pair on the Cl will attack the Al to form a complex ion. So our complex ion gonna involve the combinations of positive and negative charge at once. So we have Cl with 2 lone pair left, and then we have AlCl3. So this will be the positive charge while Al gonna be the negative charge. So do we need to break the bond already to form separate positive and negative carboxyl ions? Since we could see that there is a bulky group attached to it, means we can already break the bond between C-O and also Cl. So give all the electrons to this Cl. Note that we're gonna have extra lone pair on the oxygens together with the pi electrons. Whenever we have these two combinations, we're gonna form resonance structures. By transferring all the bonding electrons to Cl, we're going to form resonance structure of ethylene ions. So our structure gonna be like this. Double bond O, C plus, and then if we transfer the electrons from here to here, then we're gonna get 1, 2, 3. Now we're gonna have 3 carbons, O, and left with only 1 lone pair. By doing this, your carbon will achieve 0 formal charge, but then your oxygens gonna have positive charge. So you must show this resonance structure of ethylene ions during the first steps in acylations. And then we have step 2. Step 2 is the formations of uranium ions. We're gonna involve the reactions between the benzene and also the acyl group that we are going to take in. So we have this 1, 2, 3, 4 with methyl. So we have double bond O and positive charge in here. We're gonna attack from this double bond to the C positive. We're gonna form resonance structure of uranium ions. So since one of the bond has been broken, means we're gonna form positive charge in here, and then we have H, and then we have this carboxyl ion has become the CO, and then we have methyl in here. So we can move this double bond to this bonding, giving you the second resonance structure of here and here. So positive charge will be here. And then the last movement of this electron will be here. Alright, so close it with square bracket to indicate that they are all resonance to one another. And then as for step 3, we're going to take one of the resonance structure to complete our reaction. So step 3 is where we are going to lose one of the hydrogens so that we can retain the double bond inside the benzene. So we're going to take these resonance structure. So we have H, 1, 2, 3, 4, double bond O, 1, and then we're gonna react them with AlCl4. So we should show the bonding between the Cl, and the rest is AlCl3 negative because we are going to show the bond breaking. So first, this electron will go to the Cl, making them a nucleophile with negative charge, and then this lone pair of the Cl gonna take the hydrogens and then give back the double bond. And lastly, our product gonna be the benzene with 3 double bonds, and then we have this acyl group attached to our benzene together with the side product of HCl, and then your AlCl3 has been regenerated. Alright, that's all for week 10 hour 3 tutorial. Thank you.